This is an optimization question. A bus stop shelter has two square sides. So we have x here, a back and a roof as shown in the diagram. The length of the shelter is L feet, with the height and the width each being x feet. The volume is 256 feet cubed. What dimension will allow for the least amount of material to be used? We will use second derivative test to verify the answer and give the answer in 2 decimal places. So this question concerns the bus stop shelter, not the seat inside. We will ignore the whatever seat inside. So let's define L, X, S, and V first. L is length, X is the height, and also the width of the shelter. So let's look at the question. What dimensions will allow for the least amount? Dimensions for the least amount, it means that we are actually looking for the least surface area. So what is given? The volume is 256 feet cubed. So volume is given, but we need to find the least amount of material or least amount of surface area. Another word, the constraint is given. The constraint is volume. And then the objective function will be the surface area. So let us use S as surface area. We define this. And then we define, maybe we use V as volume. So just now we've said that the constraint given is the volume. Volume is given. So we know that for this cuboid, volume formula is length times width times height. But we know that the width and the height actually is same, which is x. So we have x squared. So we are given volume 256. So we have 256 equals to L x squared. We want to express L in terms of x because it's easier to express L as single variable rather than express x as single variable. L equals to 256 divided by x squared. So this is our constraint. Then we continue to find our objective function. So now our objective is to find the least amount of material. So we have surface area. Let's calculate how many surface area we have. We have x and x here, and then x and x here. So it means that we have 2x squared plus we have a back and also have a shelter up here. So the dimension is L times x for the back and then L times x for the shelter as well. So 2LX. So this is our surface area. We want to find the least amount of material. It means that we have to express the objective function in one single variable before we continue to find the values which contribute to least amount. So now from equation 1 we have L equals to 256 divided by x squared. We have to express everything in terms of x. So we will substitute L equals to 256 divided by x squared into the objective function. If we simplify everything, so this is our objective function. S equals to 2x squared plus 512 divided by x. So to find the critical values of x, so we have to differentiate as respect to x. So ds dx equivalent to, we differentiate this, 4x. So this is actually 1 over x, which equivalents to x power negative 1. If we differentiate this, so we get negative x, negative 1 subtract 1 we get negative 2. So it means our first derivative is 4x subtract 512 x power negative 2. If we let ds divided by dx equals 0, so we can solve for the value of x. So we get the value x equals to cube root of 128, which is around 5.04. How do we know this x value actually contribute to least amount of materials? So we need to use a second derivative test to verify our answer. So we will continue to use second derivative test. Just now, from the previous page, we have objective function s equals to 2x squared plus 512 divided by x, and then dx is actually equivalent to 4x subtract 512 divided by x squared. So just now we have calculated that when x equals to 5.04, we will need to determine whether it's actually contribute to the least amount of material. So we will perform the second derivative test. dx equals to 4x subtract 512 divided by x squared. So I calculate the second derivative. The second derivative, if we differentiate again, we have 4 subtract 512. This is actually 1 over x squared means x power negative 2. If we differentiate x power negative 2, it means that negative 2x, negative 2 subtract 1, we have negative 3. So it means that negative 512 multiplied with negative 2x power negative 3. If you simplify this, you multiply, you get 1024. Divide by, we bring the x down, so x power 3. So just now when we have x equals to 5.04, if we substitute into the second derivative, you will observe that actually whatever value of x here, because x is positive, whatever value of positive value of x actually contribute to a positive value of second derivative. It actually indicates that the x value is actually minimum. So we need to find L as well. From the first equation, we have L equals to 256 divided by x squared. Now we know that x equals to 5.04. So we substitute 5.04 into the L function, so we will get about approximate 10.08. So the dimensions that will minimize the amount of material are approximately 5.04 feet for sides and approximately 0.08 feet for the length of the shelter.